Video number 2, yeah, long problem, but let's just get going. So it says, what is the height of the sea at 530? So, if you notice, 530, if we take a look at this, 630 is right here. So if we go 1, 2, 3, 4, 5, 30, you're going to be figuring out where does that graph go here. And as you can kind of see over here, at 1:30 p.m., it goes up. Again, my drawing is nowhere near perfect, but if we went back 1 hour, which is right here, we would see it's getting here-ish. Again, my drawing is not perfect. So we're thinking halfway-ish between 5'3" and 6'1", just as a guess. And we're kind of hoping for that in our results. So the problem says, what is the height of the sea at 5:30? So I put in 5.5 for my x. It's 5:30. And let's see here. Yeah, so there. So I took that equation. All I did was put 5.5 in there, 5:30. Crunch numbers like crazy. So this is this. This, 2 times pi divided by 7 is this. I multiply these together. I got cosine of this. Now you'd make sure to go to your calculator, make sure this is in radians. So you'd have to go cosine of that. You get this negative number times 0.4165 gives you this. And if you add it to 5.67, you get this weird 5.41. Now that's 5.41 feet. So what I did, because everything's in terms of inches, feet and inches, is I took 0.41 multiplied by 12 inches, 4.92 inches, which is really close to 5 inches. So the whole point of this is to think in terms of 5 feet, 5 inches. And if, again, I'm sorry if this is driving you crazy, but you know, this is 6'1", 5'3", and if we're thinking it's approximately 5 feet, 5 inches, that could mean my drawing's a little off, but it does make sense that it falls into that at 5.5 would be right about here, so it's trying to make its way up. And yeah, so that's it. 5 feet, 5 inches. And see if you have questions on that. And we're going to go on to this next question. All right, going to dive right in head first. This is quite the math problem. So the question is this going to be on our exam, Mr. Cleefish? Well, I'm not going to tell you. Maybe part of it, maybe a piece of it, but it is a doozy. So let's keep going. When is the third time after midnight that the sea is 68 inches? So the thought process is, let's use this formula to find out what this formula will tell you about when any time that the sea is at 68 inches. So what I did is I converted inches into feet. Now I do know that if I was to do this all over again, I think I would stick with inches, and then I would just have whole numbers throughout this whole problem. And I was thinking about that during this problem, but I'm sticking with feet, which is going to force me to deal with some wacky decimals, but we'll work it out. So 68 inches, converting that to feet, divided by 12, 5 feet 8 inches. I'm going to turn that into a decimal right there. And that's my y. So that's what I'm going to put right here. And then I'm going to notice, I got to do some thinking, notice the answer to this problem has a lift or a vertical shift of 5.67. You know you're on the right track when stuff like this happens, because the math teacher made the problem so that it isn't crazy. Because if I subtract 5.67 from both sides, I end up with 0 equals all of this. Now I divided both sides by 0.4165, and I know that this is just going to disappear, and this is just going to turn into 0. So that's where I went over here. Now a couple of things about this. what I did is I used my noggin, but I'll explain what I'm saying in a second. I thought of it, where does cosine equal 0? I just totally ignored this. Where does cosine equal 0? But this goes back to the quadrantals. If I spin my spinner up 90 degrees, notice my adjacent side is 0, and my hypotenuse is 1. Cosine would be 0 at pi over 2. So that's where I got this. This stuff has to equal pi over 2. Now, a different way to do it is just take your calculator. If you don't like the whole spinner thing, you can go second cosine 0, hit enter, and you get 1.57 radians, which is the same thing as 3.14 over 2. So either way, you're going to know that this, where does cosine ever equal 0? Well, this stuff has to be equal to pi over 2. So I took the cosine out. I said this stuff has to equal pi over 2, or 1.57. I dealt with it by distributing. Then I got tired of this, so I turned them all into decimals. And then I solved it by adding this to both sides, and then dividing by 0.8976. Finally, we get x equals 11.75. Now, the question is, what the heck? Well, this goes back to our drawing. They wanted the third time. Well, unfortunately, if we really use our noggin, this is 11.75, which is 1145, but let's take a look at this drawing. So, look at this. So, we're over here at 1145, so there's 1145. Remember something, you guys, this is huge. This is just embedded in this math problem. The height that they're curious about, 68 inches, ends up being the same height as the vertical shift. So they're really asking at what time, or when's the third time it crosses this median here. Well, we found out 1145 that it does. But that's, look at this, 1, 2, 3, that's the fourth time, which you're thinking, oh my gosh, this problem will never end. And you're right. But here's the thing, they want this. Well, the nice news about this being right on this midline is, this is 1/2 of the period. So remember, the period was 7. So we need to go 3.5 hours back from 1145. Well, give me a second. So here we go. I'm going to say 3.5 hours back from 1145. Well, 1145 minus 3 is 845, but then I need to go another half hour back. So that would take me to 8:15, and man, oh man, was that a math problem. All right, I think that's the hardest one on this whole thing. Okay, one more of these. I don't think this one's nearly as difficult as the previous one, so hang in there. A weight hanging from the spring bounces up and down infinitely with the same amplitude. So let's talk about, well, when t is 5, time is 5, the weight is 4 feet above the ground, so there it is. When t is 7, the weight is 1 foot. So I looked at this, I knew this was 2 seconds it took to get to the bottom, so 2 seconds it takes going backwards to get to the bottom. So that's 3:1. And if I continued in this journey, 2 more seconds to the left would take me back to the peak. And if you notice something, this right here, if this is 1 and this is 4, that's 3 in between, so the halfway mark would be right here, and that's 2.5. So we already know the amplitude is going to be a 1.5. Now, we have to decide, do we want to use sine or do we want to use cosine? You can probably tell I'm a big fan of cosine, but let's check something here. And if we just stayed with this, notice this took 1 second to get right back to the mid line. If we did that and we wanted to use sine, we could. So, which one should we use? Well, if we took a look at cosine, we would say it moved to the right 1, amplitude 1.5. So we'd go y equals, here's cosine, 1.5 cosine. Now, I haven't figured out what b is yet, so I should probably do that before I start filling in more information. But as you notice, from 3 to 7, we know the period is 4. So we're going to use the period formula, multiply both sides by b. So I get 4b equals 2 pi, divide both by 4, and I get 2 pi over 4, which is pi over 2. So now I can put that right in there. I do know if I'm going to use cosine that it was shifted over 1, so I need to go x minus 1. And this thing was elevated 2.5 up, so I need to go 2.5. Now if I wanted to use sine, the amplitude's the same, the b is the same. Now here's the difference. This didn't move right or left. Remember, it goes through the origin. So we could say that's good, and then that moved up 2.5. So there's an advantage. This is a little bit easier to work with, I think, so we'll deal with sine instead of cosine this time. So there's the equation, but there's 2 of them. All right, let me get ready for part B. All right, part B. Notice it says, what was the height, that's y, when t, which is our x, is 12.5. So I popped 12.5 in right there. Radian mode, crank that out in your calculator, you'll get 3.6 feet. And if you take a look at your drawing, just to make sure, 12.5 seconds, well, we're not going to take time to do that. All right, sorry about that. All right, just going to finish off part C here. It's kind of crazy, but hang in there. So it says, when is the second time the spring has a height of 2 feet 7 inches? Well, remember, 2 feet 6 inches is 2.5, which, if we take it to our drawing, this is kind of where sine starts out at 2.5. So when is it when's it a little over 2.5 feet? Well, probably just barely after 0 seconds would be the first time. So we're looking for that height right in here. So this is going to be interesting, but check it out. Here comes the math. When is the second time the spring has a height of 2.7 inches? So this is where we're going to take our y from this graph. We're going to take our y, we're going to replace it with 2 7/12. That's 2 feet 7 inches. And then we're just going to solve. So if you can look at my work now, what I did is I converted that to 2.583. I subtracted 2.5 from both sides, and I got this, 0.083 equals this stuff. Then I divided by 1.5 just to isolate this. And I got this, 0.0553 equals sine of pi over 2x. Interestingly, when you take the inverse sine of this to figure out what angle that corresponds to, you end up getting this, which looks exactly like this, but I rounded a little bit, so they're not exactly the same, but that was kind of interesting. So that means this has to equal that, because this is the angle our calculator gave us in radians of the inverse sine of that situation. So we set this equal to this. That's what I did right here. And then I converted that just to 3.14 over 2, 1.57. I probably rounded a little too much. My answer's not perfect because I did a little too much rounding. divide by 1.57, and I get x is 0.035. That means the first time that it's at that height is just a smidge past 0, which makes sense. So what we need to do is remember that our original period was 4. It's going to repeat that in half the period. So we're going to add 2 to that. So 2 seconds, just barely over 2 seconds, which according to our drawing is slightly off, because that means a little over 2 seconds it happens again. And according to our drawing, it starts getting under 2.5. So I think I'm penalized a little for rounding a little bit too much through this process. But I hope you get the gist. Not a perfect answer, but there you go. That finishes video number 2. The rest of these videos are going to go by way faster. Kind of apologize. So here we go. See you for the next video.